Under the subject of programming with C and C++, today I am going to deal with the unit 2, that is evolution of C language. In this, the agenda, in this we are going to discuss with history of C language, features of C language and structure of a C program. The first topic is history of C language. C was a language which was developed by Dennis Ritchie in 1972 at the Bell Laboratories in USA. He worked from the early 1970s for the development of the B language. In the process of development of the language B, he tried to invent the C language. This is the same time when Thomson and Kernighan developed the Unix operating system, and they have implemented it on PDP-7 mission, and they wanted to move the same thing onto the PDP-11 mission. Means mission to mission they wanted to change this operating system. So it will be a very difficult task, it's a very difficult effort to port the code from one mission to another mission, because the hardware of one mission is different from another mission. So operating system for one mission will be varied to the another mission if it is written in mission language code. If it is written in high level language code, much of the code is written in high level language code, which is very easy to change the operating system from one mission to another mission. They are in search of that kind of programming language which has been written in high level language, which can able to understand the assembly language and mission language. At the same time, Dennis Ritchie is working with the B language. That's why he made use of this situation. He developed the C programming language, and which is best supportive to change the mission code from one mission to another mission. This is the easy way of porting the thing. This is how the C was developed. C was very much required at that moment to change the operating system from one mission to another mission. So C was used to write the first port of Unix. Ever since, most of the Unix have been written in C language itself. Only a specific small 13 portions of Unix system which handles the hardware interface, which is written in machine specific assemblers. C has become a popular language due to its simplicity, power, features and rich set of libraries. Nowadays, it is one of the main language used for software development, particularly in the area of drivers, network, system level programming. See, let us see, C becomes popular and many versions of the C have also been evolved with the different set of libraries. Though n number of programming languages have been evolved till today, C has its own identity. C has never lost its priority. Though n number of programming languages are nowadays, many of the compilers of these programming languages have been written in C itself. That is how the richness of the C depends on much of the programming languages are depending on the structure, and at least for the compilation purpose, to write the compiler program, they are dependent on the C language. So if you know the C language, then you can easily learn any other programming language that is prevailing till today. Why only C language? Why C has got this much of importance in the languages field of computer science? A good programming language should have certain qualities like simplicity, efficiency, compactness and well structured format. All these four good qualities are there in the C programming language. C is the first programming language to have almost all these good features at a place. C is having the small set of keywords. Keywords are the reserved words which are used to write a particular programming language. If the number of keywords are increased, it will be difficult for us to remember all those keywords, to make use of all those keywords in our programming language. So, keeping in this point in view, C has used very small set of keywords. Strong input-output capabilities. See, to do any program, we need to take input, we need to process it, and we should give the output. In order to receive the input, there should be some strong set of functions should be there to read the inputs, and to give the output, again it needs some strong set of output functions. All these strong input-output functions are there in C language. C is also well structured programming language, as this is the best example of structured programming language. This is the very famous structured programming language. All the structures are very much syntactically already written in the C language, and which is very simple and easily understandable, and it is also modular. So, we can divide the program into number of functions. Functions can do individually its own work and can be called by another function n number of times, so that the reusability will be increased. Availability of the supporting libraries. Any programming language richness will be dependent on the libraries that it have, because libraries will include so many number of built-in functions, built-in classes and all. So, n number of built-in class functions are already there in the C library. If we could able to make use of the C library functions, it will be very simpler to write a C program. Without writing the code in the function, we can directly call those functions and make use of the code which is there in the functions directly by calling them from the libraries. User controllable memory management. Memory management is one of the most prime important concept in any programming language, because as we create n number of variables, we allocate storage for n number of variables. All the storage will be kept aside when we complete our task. There should be definitely some memory management mechanism should be there to remove the unwanted data from our memory. So, this can be efficiently done. User controllable memory management is there in the C, so that user can identify which set of variables or which data storage is useless, that he can remove, and he can allocate the same old storage to another variables, so that memory management can be efficiently done. System level programming support. Yes, C has been written in high level language. It can easily adaptable to the assembly language, and it can easily be converted to mission level programming language. So, this system level programming support is very much possible with the C program. That's why only the compilers has been written in C language. That's why C has been the most prominent language. I think 90% of the compilers have been written in C language itself, and C is a mission dependent. This is how Dennis Ritchie has proved it, because he has invented C just to port from one mission to another mission. So, as I said earlier, to port the operating system from one mission to another mission, that operating system has to adapt those mission level instructions of one mission to another mission. If it is mission independent, means whatever it may be the mission, either it may be the desktop, or it may be the laptop, or it may be the hand top, whatever it is, but we can, either it may be the mobile, whatever it may be the mission, whatever it may be its bus capacity, either it may be 16-bit, or it may be 32-bit, or it may be 64-bit mission. These are the bus capacities and data buses capacities. Whatever may be the address bus, data bus capacity, if it is a mission independent programming language, it can easily adaptable to that mission language program. So, C has that rich set of mission independence. Features of a C language. It is robust. The good feature of a C is it is robust. What is robustness? The ability to handle errors during the execution and managing the incorrect input of data. See, if the error occurs, it should not go into an infinite loop. If an error occurs, it should be in a position to debug it. At the time of execution, the execution should not stop. It should be in a position to handle that error. The error handling capabilities with its rich set of error handling functions, it can easily overcome those errors and make the execution of the program simpler and easier without any hurdles meanwhile while doing the execution of the program. Rich set of built-in functions and operators. See, as I told already, C library is the richest library in itself in any program compared to any other programming language. It also contains its built-in functions. So many and thousands of built-in functions are already written in C and will be kept in the C library. Our responsibility is only to identify those built-in functions and should call them into our program, make use of those functions, and without writing the code for those built-in functions, those code is already written in C, while in the C compiler itself, that built-in functions are already been written. Only our task is to retrieve those functions and make use of those functions in our program. So, it supports assembly language with features of high level language, which is required by any system programming language. For that sake only, C is not only called as high level language, it is also called as machine level programming language. Any programming language is divided into three types. Either it may be machine level, or it may be high level, or it may be middle level. If it is a machine level programming language, it can only be understandable by the system, means it is written in the binary codes, zeros and ones, but it is not understandable by the user. User need to understand the same old machine level language code into higher language code, means in our simple C English statements has been written in the higher level language programs like C, C++. All these programming languages are higher level programming languages. So, there need to be a compiler to transfer these higher level language programming instructions into machine level language program instructions. So, compiler work is to convert this higher level to machine level programming language, and the output that has been come from the machine level language should be converted again to the higher level programming language to make it understandable to the user. So, C is very much adaptable. It can access as a middle level language as well as it can access as a higher level language. With that only, for the best its complement, we are using the C for the compilers. C programs are efficient and they also run faster than any programs written in another programming languages due to its optimization of code and closeliness to the assembly language. As in the previous point we have said, it is very close to the assembly level language program, which is a middle level language program. As it is very much close to the middle level language program, it will be easier to convert into mission level language program. So, the time complexity will be reduced to convert from high level to mission level language, because it can easily be adaptable to the assembly level language program. So, they can be run faster. I mean, the compilation time will be very much less in the C programming programs. C is almost portable, which means the program written in one mission can be run on another mission without modification. This itself is called as a portability. Portability means an adaptability. If a program is written in one mission in my computer, with 32-bit computer, can easily be executable in your system which has been written, let us take which has been a 62-bit computer, 64-bit computer. So, irrespective of the mission, C can easily, if it is written in my system, it can be executable in your system, means it is portable, it can be run anywhere. It can be extendable by the way of libraries and defining the new data types. Not only the built-in data types that are there in C language, we can also write our own built-in user-defined data types and extend the capability of the C language as much ever as we expect. The structure of C program. Every C program consists of one or more functions. Each of these functions perform its own tasks. Function is nothing but doing a particular task, set of code to do a particular task. So, each of these functions perform their own tasks. The results generated by these tasks are passed between the functions in several ways. A special function called as main function should be declared in any program which acts as an entry point for the entire set of functions. The execution of the program starts with the first line of this main function, and other functions are called from within the main function either directly or indirectly. See, means whatever it may be the program, it should start its execution. The cursor starts, the compilation process starts from the main function itself. In the main itself, we are calling all other functions. There is no rule that the function main should be the first function in the program. Yes, main should be there in the C program, but it's not mandatory that main program only should be the first function that should be written in C program. Wherever you write the main function in your C program, irrespective of the place where it has been written, the execution starts from main itself. So, it is not mandatory to write the main at the beginning itself. Each statement within the block must be terminated with a semicolon. Whatever the statement that we write in C language should be ended, terminated with a semicolon. So, that's why it is also called as statement terminator or delimiter. Semicolon is called as statement terminator or delimiter. Suppose a block of related statements are enclosed with curly braces. If you want to write the block of codes, they should be enclosed in a curly brace. This is also known as block of code, is also called as compound statements. In C, as semicolon is a terminator, it's not compulsory to write the entire statement in a single statement. If you wanted to write a code or else a statement in a more than one statement, you can continue the statement till you give your semicolon. It's not compulsory for each and every line you have to give the semicolon. Wherever you give the semicolon, that it treats as a single line statement, though if you write more than one line. Phases of execution of a C program. A program in any high level language is written in a simple English text file with appropriate extensions. The extension of a C program is .c. Then after giving a name to any program name .c, it will be compiled to generate a machine language code which can be run by the user as a command. So, because as it is a high level language, we are writing it in a high level language C program, it has to be converted into machine level language program with a C compiler. C also, like all other programming languages, C also follows the same old process, but in the process of doing the compilation, it has the several stages before going to the final compilation takes place. The compilation and the execution of the C program is done in these 4 phases: pre-processing, compilation, assembly and linking. Pre-processing is nothing but, see, at this first stage of execution, whatever the C file is written, all the comments that we write in the C program will be first stripped, and the broken lines what we write will be joined. Then the line starts with the hash character are interpreted by the preprocessor, and the appropriate modifications are made on this code. Preprocessing is a simple macro language with a small set of syntax and semantics, which helps in reducing the code repetition. In this case, the hash include instruct the preprocessor to include the contents from the stdio.h header file into the present source file. stdio.h is a header file which should be taken from that header file library, which should be dragged from that place and should be kept in our preprocessor. Next is a compilation. In this stage, the preprocessor code is translated to a human readable assembly language instructions known as intermediate code, which can be understood by the assembler specific to the machine. Next is assembly. The assembly code that we have already generated, that the assembler is used to translate this assembly instructions to the binary object code, which consists of actual instructions to be run by the target processor. Next is the linking. the object code, the code that it has already compiled or else come to the machine language code, here the linking process will be done in the linking stage. The object code consists of machine instructions given in the code, but it does not contain the code from the libraries used in the program, and some addresses may not have been referenced properly. The order of code may not be in a proper way. All these things will be checked in the linking stage. The linker will rearrange the code after adding the instructions from the library functions used by the program. In the example, the linker adds the code of the print function, because as print function is there in the stdio.h header function, that printf function we are using in our program. Let us see how we are using. First C program. This is the program, this is a sample program that prints hello world. See, the first statement is hash include stdio.h. stdio.h has been written in angular brackets. The next statement is int main, in parenthesis we have written void. Let me explain all these things. After that, the compound statement, nothing but block of code. In that block of code we have written only one statement, that is printf welcome to C programming. Then it will return 0. Return 0 is a terminator of this program, which has been terminated with semicolon. Even the printf statement, you just see the printf statement is also terminated with a semicolon. Return statement is also terminated with a semicolon, but we will not use any semicolon at the beginning of the function. We have not written the semicolon in int main void place, because there itself the function starts. Only the statement delimiter is a semicolon, not the function delimiter. Semicolon is not the function delimiter. See, let me explain this. Let me explain this program. First, see, first what we have written in comments. First C program that prints hello world has been written in comments. Did you observe the comments? Slash star star slash. This is the way of commenting. Comments are of two types: documentary comments, single line comments. Suppose if you want to write any comment in more than one line, you can use these documentary comments like slash star star slash. More than one line can be written in between them. So that's why it is called as documentary comment. Another kind of comments are there which are of double slash. So before the line, if you put two slashes, that is treated as single line comment. Why we write comment to a program? Is it required to write a comment to a program? Yes, it is required to write a comment to a program, because suppose if you write a program, after that if you want to explain it to somebody else, or else after 6 months or after a year, if you want to explain it to somebody else, otherwise somebody else is reading your program without your presence, how they would know for what purpose that you have written your program? How they would know for what function that you have written? Suppose if you indicate them, if you explain them with your simple words, simple English words in terms of comments, without any other person interference, they can easily understand the program purpose, program functions that we have used in that program. So it's not mandatory to write the comments, but it is a good practice to write the comments for each and every program if needed for each and every function. That's why we will write the comments. And I would like to tell one more point. Whatever it may be whatever it may be the comment that you write with these comment symbols, it will not be executed. It will not be executed. This is only to read, to make other to understand the program. That's it. It will not be executed by the C compiler. So you can write as simple as such. Whatever that you wanted to write regarding that program, you can write it in the comments. It will not be executed. So execution will not be done by the C compiler for the comments. And the next statement is hash include stdio. This hash symbol indicates that we have to take the instructions from the library. Library functions, header functions are there in the hash stage. So if you see, if you encounter the hash symbol, compiler will think that I have to collect the information from the header files which has been specified. Here the header file is stdio.h. Because how it knows that it is a header file? It has been kept in the angular brackets. Just by seeing those angular brackets, it will identify that it is the header file. It has to drag that header file from the C library and it should make use of that header file in our program. Here why we are using this header file only means stdio.h means this is standard input output header file. So this header file includes all the built-in functions which are used for input and output purpose. The name itself says it is standard input output header file. So whatever the input related functions that we are using in our program, whatever the output related functions that we are using in this program will be dragged from the stdio.h header file. Next statement is int main, in parenthesis we have written void. What does it int main means? Main is a function which has to be written the int value. The return type will be written just before the function. Here the return type is int. So int value is returned by this main function. That's why we have written int main. In parenthesis we have written void, means it is not taking any parameters. It is not taking any parameters for this function. Void indicates null. So it is not taking any parameters in the main. Next, block of code starts with the curly braces. That block of code shows printf. In that block of code we have written printf function. Printf function is nothing but the standard output function, which to use this printf function in our C program we have included stdio.h here. Did you understand now why we have used #include stdio.h? This stdio.h contains the built-in printf function. So we wanted to make use of that printf function in our program. That's why we have included stdio.h in our program. So as we have included stdio.h in our program, we can make use of printf statement, printf function. So in the printf function, we are just giving the parameters as welcome to C programming. As the built-in function structure is like that, so we have whatever that we give in the double quotes will be simply outputted. See, we have not written any code for the printf, just simply we made use of the printf in our program just because we have included stdio.h here. And the next statement, last statement is return 0. Why we are returning 0 means, as this is the main function which is returning the integer value, here nothing is there to return. That's why we wanted to return 0 value as an integer return type. That's why if you don't write int main, just if you simply write void main, it's not required for you to write return 0. As we have written int main, definitely this function has to return something in return. That's why we have given return 0 statement in order to return something from this main statement. Next, there is a preprocessor directive. This is how that we can execute any C program. Same statement. This is how we can write a C program. After writing the C program, we can execute this program with a C compiler and run the C program in order to get the output welcome to the C programming. The output of this program is welcome to C program, as we have mentioned in the printf statements. In this, we have completed pre-processing, assembling, linking, compilation process in the step-by-step way. This is how we can write any C programming. As this here we have used only main function, we did not use any other functions in the main program. If we wanted to use, we can include any number of functions in the main function itself. This is the simple way of writing a C program. Thank you.